This is example 11.3 from Discovering Design with Chemistry. All right, so what we're going to start with is figuring out with this, what is the chemical equation for the reaction between HCl and CaOH2. So this one has an H at the beginning, so we know that this is our acid. And then that means that this one has to be our base. So let's start by just writing the beginning part of our chemical equation. So we're going to have this one plus this one, and that yields. Now, we know that the H here is going to connect to something over here. And in fact, this is our thing that it's connecting to, because our reaction is going to make water plus a salt. So we have to figure out what is left. So if we take the H from here and put it with the OH here to make water, that means that what we're left with is the CaCl. So we're missing some subscripts and some numbers out front, so let's figure those out real quick. Okay, so the HCl, let's do this over to the side. In this case, it came from, this is, sorry, like hydrochloric acid. This one, when it donates the H plus, and we're left with the chlorine that's going to connect with the calcium, this one is going to have a minus charge. And then the calcium, we know, you can look at this in two different ways. You can either know that the calcium is in the +2 because it's in column 2A, or you can recognize there's an imaginary 1 here, and we must have taken whatever the charges were for these two things, this, and swapped them to get those subscripts. And so I'm going to take away the imaginary 1. Oh, I wrote that before the OH. All right, so this imaginary 1 here that I'm about to subtract is going to come up to the OH. And we can just write that simply as just a minus. And the calcium has the +2 charge. So when we put calcium chloride together, we have a +2 and a -1, and so we swap those. So this ends up with a 2 here. All right, so we've taken care of that. Now with the H2O, let's look at something different before we start attempting to balance this. We have 2 hydroxide things here, which means we can make 2 water molecules. But to do that, that means we must have also had 2 of the hydrogen ones to come over. So we can go ahead and add a few of our numbers out front just by looking at the different things that make up this chemical equation. Okay. So now let's start comparing the different things. We have H's, Cl, Ca, O. All right, so we have H's in 2 places over here, so we're just not even going to deal with that one yet. Let's go straight to the Cl. We have 2 on the left, and we have 2 on the right. Calcium, we have 1 on the reactants, 1 on the products. Oxygen, we have 2 here, and we have 2 here because of that number out front. So those are both 2. Now let's look at our hydrogen. We have 2 here and 2 here, so that's 4. And then on this side we have 4. So it balances. So we're done. If you had not recognized or realized that having 2 of these OHs would work together with hydrogen to the H plus, the hydronium thing, to make 2 of those, and you hadn't put this 2 right here out front or this 2 out here second, that would be okay as long as you got, the important thing is to get the reactants written correctly, which are given up here in the question, so that's not too hard to do. And then on the other side to make sure that you put H2O because it makes water, and then to figure out what the salt is. The salt you can just figure out like we did before by taking these 2, and you can either recognize that which columns they're in are in +2 and minus, and then swap those charges like we did, or you can use the things that they're already connected with. You can see that, especially if you know that H is the plus, then you can see that this is a minus. And because this has a 2 down here, you can know that this must have had a 2 plus and a 2 minus when they start splitting up and breaking apart. And you can use those to help figure out what your salt is. So there are a few different hints to help you figure out. All right, I can't get that cleaned up. We're just going to rewrite it. All right, so there's your balanced equation. Let's look at the second one. So the second one in example 1.3 says, what is the chemical equation for the reaction between H3PO4 and KOH? Again, here is our acid because it has the H, multiple H's we're going to donate. And then here's our base. And you can tell because it has this, this hydroxide ion. So this one is actually going to, I can tell because it has a 3, it's actually going to contribute 3 of these to over here, which means we're going to need 3 of these to go with it. So let's start by just writing the first part of our equation. So we have H3PO4 plus KOH. So what will that produce? We know that these and these are going to connect, and that's going to make our H2O. And then what's left is our potassium and our PO4. The question is there a number here and here that we need to worry about? So because this had 3 pluses, this must be a -3. And because this has a -1, this must have a plus. And you can also find that out by knowing some of the things about where they are on the periodic table. So this one, our K has a plus, our PO4 has a 3 minus. And I got those from here and oops, not there. I don't know why I subtracted that one. Here and here. And so I really should write them here and here so that then I can think I'm swapping them down to these sides. So this one becomes 3, and then the PO4 has a 1, but we don't write that. All right, let's clean this up a little bit. All right, so now let's start checking our numbers, see how things are balancing. All right, so what we're worried about are H, P, O, and K. All right, so there are H's in 2 places on this side and 1 place on this side. So let's not even deal with those yet. Let's look at the P's first. So we have a P on the left and a P on the right. And then we have on the left, and there's one thing I could point out, that we have 3 here that we're probably going to need to put them with 3 OHs. So this, we could go ahead and start with that and start mixing things around. Or we can start just with no numbers out front, no coefficients. I don't know if that's actually what they're called, but that's what I'm calling them. And we can just kind of work it from there. So that's what we're going to do this time. So I'm not going to put the 3, even though I assume that there's going to be a 3 there. And we're going to add to it as we go. So 1 P on each side. O's are in 2 places on both sides. That's going to be the absolute last one we deal with. And then K has 1 on the left and 3 on the right. So let's go ahead and fix that. So there's that 3 that I knew was coming. So now we need to change some numbers. So let's look again. All right, so now we have, again, well, the P's didn't change. I didn't need to erase that. And then the K's, we have 3 and 3. So that's good. All right, so let's, because the H's are in 2 places on one side, but only 1 place on the other, whereas the O's are like everywhere, let's do the H's next. So we have 3 plus 3, that makes 6. And over here, we only have 2. So let's go ahead and change this to a 3, and then we'll have 6 of those. All right, so now because we put a 3 there, we can count our our hydrogen again. So we have 3 plus 3 is 6, and now we have 6 here. We're looking okay, but we're about to start messing with the oxygen, and that's probably where it's going to blow up. All right, so we have 4 plus 3, that makes 7. And then here we have 3 and then another 4, and that makes 7. So actually, we're doing okay. So let's do one final check to make sure we have the, why is that not erasing? There it is. All right, let's do one final check to make sure that we have all of our numbers right. So hydrogen, 3, 3, that's 6, 3 times 2 is 6. P, 1 on the side, 1 on that side. O, we have 4 plus 3 makes 7. 3 plus 4 makes 7. And then the K, we have 3 here and 3 here. So we're good. So this is our final chemical equation for that number. Again, we identified the acid because it had an H out front. We identified the base with this OH. And then we created our water plus our salt that we needed to, and then we balanced the equation.